Wave check.
A mechanical wave is a disturbance or oscillation that transfers energy from one point to another without permanently displacing the particles of the medium. There are two different types of mechanical waves: longitudinal waves and transverse waves. In a longitudinal wave, the particle displacement is parallel to the direction of the wave. In a transverse wave, the particle displacement is perpendicular to the direction of the wave. The parts of a wave. The wavelength is the distance of one oscillation. The amplitude is the height of the wave. The period is the amount of time it takes to complete one oscillation. The frequency is the number of oscillations completed in a certain time. The wave speed is the speed at which the wave travels at. A crest is a point of maximum displacement. A trough is a point of minimum displacement. Waves also act differently at different types of boundaries. When a wave reaches a fixed end, such as a knot, it inverts. When a wave reaches a free end, such as a ring, it stays in the same direction. Wave interference is when multiple pulses meet and interact. When two waves whose displacement is in the same direction meet, their interaction is called constructive interference. The two waves combine, creating one wave with a greater displacement. If the waves are in opposite directions, then their interaction is called destructive interference. These two waves counteract each other, creating one smaller wave. If the two waves have the same displacement in opposite directions, then destructive interference cancels them out. Sometimes, when the frequency and other conditions are right, a standing wave is formed. In a standing wave, certain points appear to be fixed or not moving. These points are called nodes. There are also points of maximum displacement called antinodes. There are also modes to standing waves, each with a specific wave pattern. There's the first harmonic, also known as the fundamental, the second harmonic, the third harmonic, the fourth harmonic, the fifth harmonic, the sixth harmonic, and so on. Let's do some sample problems. The basic equation used to calculate different parts of the wave is wavelength equals wave speed over frequency. Say I send a 0.02 meter wave pulse through my wired AirPods. If the pulse travels at a wave speed of 5 meters per second, what's the frequency? We can rearrange the wave speed equation to solve for frequency and then plug in the values given to find out that the answer is 250 Hz.